Putting a little masking tape between the meters here, so we can drill right in the center once we establish it. What we did is made some cardboard cutouts 3 inches in diameter. That's the diameter of the Variac. I placed it in the back, and there's clearance between the chassis top and the meter sides on the back. So it will fit. So in order to get the dead center, I trimmed a piece of masking tape between the meters. So when I remove them, I'll get the dead center here, and I got to establish the height here as to where the meter will go. And we'll probably use this, making a center hole in this as a template. And you'll have 2 round openings for the meter, so we should get that in there perfectly. We're going to remove the 12 volt, 5 volt transformer, and we're going to put in 1N 5408 3 amp 1000 PIV diodes. And we're going to use 2 of them in series on each rectifier. I got the voltmeter out, and as you can see, she reads perfectly this way, and she's off balance this way. So this front pops off very easily, so I put a little piece of Scotch tape over here and over here. So all I got to do is just cut it with a razor blade here, if I have to remove it to center this again. So we got 1 meter out. We've got a green lead that goes to the positive. That's just the way this thing is wired. They don't certainly go by proper color codes, that's for sure. The positive has the green. I've already photographed this. And the resistor that I put in right here, the 100,000 ohm, is on the yellow wire. So that's exactly the way it is. When we're going to drill in this panel, I got to get the meters out anyways. Now, that circle that I showed you right here will fit down there perfectly once I get this other meter out. And it'll be about a 1/4 inch off the chassis, so it will not touch the chassis. We're going to remove this after we remove the other meter, and this will go. I may put this back where it was, or I may relocate it somewhere else. Not sure yet. It's no big deal. That's just the way they made it. Eliminating the 5U4, and we're using 1N 5408s, which are 3 amp 1000 peak inverse voltage diodes. We're using 2 of them in series. We're originally going to use 1N 4007, but I think we'll go with a better one. This is the label that came off the filament transformer. I don't know if you can read it, but it's got 1200 volts insulation, 5 volts, 3 amp capacity for the 5U4. That was on top of this transformer here. So we'll just glue that back on, and we'll put it into inventory, because we won't need 5 volts anymore because we're using solid state diodes. So this thing will not have any vacuum tubes in it at all. So we're going to remove the other meter. I'll be right back. Okay, got the milliamp meter out, and just for safety reasons, I put a piece of Scotch tape here and on the bottom, although this panel front bezel does not come off easily like the voltmeter did. I don't want to take any chances. As you can see, this meter is pretty well balanced. We also got loose screws here too. Well, we're not going to worry about that. One thing that bothers me is when I took off this outside screw here to get the wire off with the lug on it, the inner nut was very loose. And as I said on another one of my videos on this project here, you don't want to really tighten these up because I've done that before and ruined the meter and lost connection inside. So I hand tightened it, but I don't want to put a wrench on it. It works. Don't break what is working. So now we've got this hanging. We know what where the wires go. And whether we're going to put it back in here again, that I don't know. But we got to remove the filament transformer. And there is only 3 wires coming out of the filament transformer. 2 for the primary and 3 for the secondary. Secondary has a center tap on it. Secondary is 5 volts with a 3 amp capacity to filament the 5U4. It has a center tap on it which goes to the main filter, which is over here. Alright, I sandwiched the metal faceplate between 2 pieces of wood, clamped it as tight as I can get it. I did this side already. It's still a little, you can feel it, but you're never going to get this perfect. I don't want to take all this out. I'd have to disconnect the binding post, unsolder them, and take them all out and everything, and then when I try to solder them back up, it's going to be sloppy because I can't do neat work because I can't see what I'm doing, so we'll just leave it alone. We're not that bad. I straightened out quite a bit of it, just like I did with the cabinet down there, as much as I could. So what we have here, we're pretty good. We have a little bend here, but very, very little. Well, we've got a little crease there, but it's overall, it's pretty good. It's as good as I can do. I mean, yes, I can take the whole panel off and hammer it out. It'll never be right. But a lot of this could have been there anyways. I don't know, because the auction pictures never really showed all that much. So now what I'm going to do is, off camera, I'm going to disconnect this transformer here. And then I can commence to take measurements in the dead center here. I just want to be able to have something I can put a mark on without marking up unnecessarily here. And where the Bushler logo is, that's probably where the Variac is going to, the knob is going to be. I don't think we can use this here though, because the meters come down right over here, and where I got to go is up high enough to get off the chassis. So I won't be able to use this. It'll just be the knob on the Variac, which fits between the meters. Not a problem. I've made very sure of that. But we can't use this. But this is on the side originally anyways. Right over here. Looks like about a 3/8 inch hole there. So you're not going to be looking at that gauge anyways. You're going to be looking at the voltmeter on the front. I probably won't even worry about filling that in. I want to paint this, and I also got to get my screwdriver in there and bring this up. Although it's not going to have any more tubes in here. 5U4 will be out, so you really don't need to worry about ventilation, but we'll straighten it out. And this is where I had to bend up the best I could do. It's not perfect, and it will need painting. All right, we got the filament transformer out. We'll put that label back on it later before we put it into stock. What they did here, this is the 5 volt for the 5U4. This is the center tap for the 5U4 filament. And what they did is, this is where you got the B plus off. As you know, 5U4 is a directly heated cathode. So the filament and the cathode are all in one. So these went to the filament pins of the 5U4, which is also served as the cathode. And they got the B plus off of this, which is the center tap of this. And then this side is the AC winding. All right, this is where the center tap was connected. You can see a little piece of it right here if you look really close. So this is where the output of the B plus is going to be going into. So it's on the one side of this 150 ohm resistor here. So we'll be putting some diodes in here. We won't be doing that just yet because I'm going to be concentrating on the top side of the chassis. So we're going to take some more measurements because the worst case scenario, if we have to put this thing back in, if it don't work out for us, it's not going to fit under here. So we're going to have to probably put it all back originally, and I don't think we have to do that. But I needed to get these meters out and the transformer out so I can make very sure that's going to fit in there, which I'm pretty sure it will. Well, I don't know the angle at which I'm at. Not very good, but this was the outside diameter. That's a 3-inch diameter, and I pushed it up as high as I could to allow clearance for the meters. And about a 1/2 inch from the chassis top. And the worst case scenario, these are solid wires, and to have 500 volts on them, it doesn't seem right. They should be heavier than that, for insulation reasons, that is. But if I have to, I can pull these up to these holes, but they'll probably be too short. So the thing now is to take the Variac. I made this 3 inches. I measured the Variac as close as I can tell. It appears to be 3 inches. That's 2.84, so that's under 3 inches. So we want a little leeway. So if we can get the circle, we'll show on this other circle that I got. That's why I made 2. It don't really matter if they come up to the plastic of the meters. The round part right here. But I'd rather have it not touch it, because we got that slider that goes around, but I think that would be sticking beyond that towards the power transformer. So it's best to mark them from on this side because we need the center, as I said. Now we're going to have 2 screws that I mentioned for the meters. Which are going to interfere with this. Well, let me take this knob off. We'll use that as a centering for making this hole here. I can't find my compass right now, so we'll do it this way. We'll take this knob off and we'll check. I think it's a quarter shaft, quarter-inch shaft. I'll be right back. What I got to do is take this and put it on the front and drill a small hole, and then use my step bit to make it larger. Although this is 1/4 inch, I'm pretty sure. The threads, I'll go measure that right now. Probably, I would say a 3/8 inch hole like I showed on the cabinet. 0.36, so that's about 3/8. The shaft measures 0.24, so 0.25 would be a 1/4 inch. So that's about 3/8. That's okay. So what we're going to do is we're going to try to center that, and we'll mark it with the marking pen where we want to be with the hole, and then we'll do very careful measurements. I want to try to get this up as high as I can without having the coil of the Variac hitting the plastic of the meters. It's going to be very close. The depth between the front panel and the power transformer should be okay, as long as I can get this in there with the shaft to push through. If not, I'll have to loosen these 4 bolts, and I think I can slide the power transformer back if I have to. Okay, by measuring, making up a little piece of paper here, we come down to the top of the chassis. That hits the chassis right here. Okay? So when you put this down here, this is the top of the chassis right here. Same with this side. So we draw a line here. This is your Variac. We're still away from the meters, and we're a good 1/2 inch or more off of that. So those wires really shouldn't be in the way, but if they are, I'll have to relocate them, which I really don't want to do. Now, this could come up a hair more. Now remember, this thing here we have this flange here. So we're still under 3 inches with the flange. Just a hair under. This is 3 inches or 3.01 inches by the meter. So this comes up against the plastic. That's going to limit how high it can go. So I'm going to put a mark here. That's why the masking tape. Put a mark here and make sure I'm centered. I'll double check myself and make sure I'm centered, because we don't want to be off either way. I think we're pretty good. And judging from this, without measuring it, I would say a good 1/2 inch, 3/4 of an inch from the top of the chassis. Okay, we just put this off to the side here. That's a 1/2 inch, just a hair over. There's our hole, as close as I could tell. That's in the center. But we're going to double check it with the tape here, because I trimmed the tape off between the meters with a razor blade. So we want to make sure this hole is in the center there. So I'm about 5 3/4 inches from here and 5 3/4 inches from here to the hole. But we're going to double check it. Very sure. You measured 3 times and drill once. Okay. Boy, that step bit went right through that like nothing. Just like butter. You can't beat American-made tools. This Chinese garbage, and used to be years ago, Japanese tools were garbage too. They'd break all the time. Drill bits would be dull. So, Ryobi makes good tools, but not drill bits. Anyways, we got this in. This is temporarily inserted here for now. You can see the space I got underneath here. I don't have to move these it It's still a little loose, and I tighten it with my fingers, but, you know, this panel is a little flimsy anyways, but when it's in the cabinet and tightened down with the 6 screws that hold it in, should be okay. And of course your wires are up here. That resistor here may be located somewhere else, but that's not a problem. So we've got good clearance on each side, so we'll have no problem with the meters when they come in. The problem's going to be down here. With the 2 bottom bolts for the meters. There's 4 bolts on each meter here, but I may not be able to put those in. I mounted the resistor here. I added a terminal strip. I got almost no terminal strips. I can't believe the prices on eBay for terminal strips. They're outrageous. They're insane. So I moved this here. I added a longer lead to go over to the meter here, and I had to cut them 2 bottom screws off. I had to use a bolt cutter, a small bolt cutter, to cut them off. I thought I could put the Variac in with these sticking out at the bottom. I had the meters all in and everything, but it stuck too far inward and I couldn't get the nut on the front. So I had no choice. I had to cut them off with the meters in place. I didn't want to do that. I tried trimming them off, you know, tightening them up and then cutting this off. And I couldn't get the bolt cutter close enough to it, so there was about an 1/8 inch stub coming out of that. I couldn't do anything with it, so I backed the nut off as much as I could, and I had to cut them. So you might see something in here, and what I did, I put some of this double-face tape on the Variac that faces the panel. So that brought me away from the panel, because the Variac wouldn't tighten up. It kept spinning, and I would have had to cut another hole in the front panel for that little tab. So I figured this would do just as good, and it fits very nicely in there, and I was able to get a lock washer on the outside and 1 nut. Under the Variac, I think you can see that. A lot of stuff in the way. But I got a good 1/2 inch between the bottom of that Variac, and I got plenty of room here. All I had to do, I moved this transformer back as far as I can get it, and it's fine. All I had to do was just push this panel a little bit like this. This panel hangs over a little anyways. Got it into the hole there with the double-face tape. It's stuck to the panel so it don't spin around when I put the nut on. So now what we want now, the Variac is on the unit. That's what we want. Next step is to put the diodes in. I'm not doing that on this video. It may be on the next video, or it might be on this video, because I may have to cut it back a lot. This is not going to fit here. But a knob, a smaller knob, without this big flange on it. This is a quarter inch shaft, round. There's no flat spot on it. So I need a knob with a set screw. It would have to be this type of knob. You couldn't use a pointer type knob like a chicken head. You couldn't do that. And then I got pilot light, and also my other pilot light came in. There's like screws go in the back. I guess this little cover comes off, I think. if I put it up here, I don't want to be taking these out again. The less I have to handle these meters, the better I like it. But the high voltage flashing light could go here, or could go here. When my sticker comes in and I decide where to put that, then I'll decide where I'm going to put the warning light, but the pilot light is going here. All right, I got the hole drilled out to 5/8, and we're getting ready to insert the pilot light. I've already got the wires soldered on here. It's much easier for me to do it here and then feed it in from the front, and we're putting a couple pieces of heat shrink on it. I don't even know if this is in camera or not. I really don't know. Okay, I got the pilot light all ready to be inserted here. Okay. And we got to put this Chinese washer and nut on here. It's going to be fun tightening that up. All right. Let me show you what I did here. Hang on. We got 1N 4208s, is it? My mind is like a sieve. They're in series because of the peak inverse voltage. And we added the B plus wire over to here, where the center tap of the 5-volt 5U4 filament winding, which is also the DC output winding, was. So we tested it and it works very well. Okay, I got it in. It's hand tight. I tighten it from here with the little knurl here on the nut here. If I get a pair of pliers in there, I'll bugger it all up. We got to make the connection to the AC, which is up here. The AC input, because this is a pilot light. Now I got these wires a little long, but I can re-tin them again. Cut them back and re-tin them again and put them in here. Okay, I got it clip leaded in temporarily. I always like to double check my work. You flip this on, and there's our AC power. So at least you can plainly see this thing is on with the light that bright, and that's the way I like things, so I can see them. So this is the pilot light. As far as the over voltage, I haven't decided yet, but I got to show you something that I said I was going to show you, and I'm not sure how I'm going to go about it, because it's going to be a huge job. I didn't forget anything, I just didn't measure right. All right, damn thing's off center. It's too far to the left. Damn knob won't fit in. Now this is not the Variac knob. I've got a few radio knobs, but I've got very few. When I had my shop in the attic, I had several hundred knobs. Oh, I'm not going to be able to do that. I have to operate this with a screwdriver. That's ridiculous. Might have to live with it. This will fit right between it. Right here. But you can see this is off center. I did such careful measurement. Obviously, when I drilled the pilot hole, the drill probably slipped. That always happens to me all the time. It might have. It didn't seem like it, but obviously it did. And then when I used the step bit, well, once you get the center off, the whole thing follows. So there's no way I can move that over. What I would have to do is take out the Variac, which is going to be an SOB job, because of the double-face tape that I use to keep the thing from turning. Then I'd have to file the right side of this hole to get it over there. And I'm going to have all those filings in there on the chassis and everything. I'm going to have to file it with the meters in. I don't really want to take them out again. I could. Right down there between the panel and the Variac, I have double-face tape. So I peeled it off and it's sticky on both sides, about an 1/8 inch thick. So that keeps the Variac centered pretty well. Best I can by eye. It's easy to get it out, but it may not be easy with the tape that's on there now. I'll have to think about that one. Well, I gotta take this out. It bothers me I can't get a decent knob on there. So, I'll be very careful. I've knocked wires off of this already, but I took a photo of it, so I'll make sure they go back on the right way. That's what happens when you can't see good, but hey, I'm doing the best I can. Okay, I removed it and had to file it with a rat tail file. And now my knob will fit in there. I didn't tighten up the set screw yet, because I got to tighten this up. I want to make sure it was centered. And I got to get my magnifying glass and see how much clearance I got on the flange of each meter here to make sure that it's centered before I tighten that up. Be back. Okay, I got it working. It's not exactly what I wanted. I wanted to use the little bezel over here, but obviously not, because I can't go down here. Obviously, it'd be below the chassis. So, be between the chassis and top and bottom, and that's impossible. So it's all right. It looks good. I think we're doing all right. Okay, I got the pilot light wires soldered in. At this time, I'm not going to do anything with the high voltage warning light. It's not really something I really want in there. I want something that's going to flash and blink when it gets over 100 volts or so. But I guess I'm not going to get that. So, another thing too is, this is soldered so nice here. Even though it's fused on the neutral, I'm going to leave it. I'm going to leave it. That's the way they did it. Apparently, it's done at the factory. They must have had a reason for doing it. I'm going to leave it. It's not going to hurt anything, I don't think. I was going to change it, but my soldering techniques are very, very sloppy. I have to do a lot of tack soldering. I had to tack these on. One, I got into a hole in the terminal strip, no problem up here, but over here I had to tack it on. I had to tack a wire on to the Variac. You can't see, you just tack it on there, and that's good enough. It's not going anywhere. All right, so at this time, I think we're going to run the test on it now. Let's turn this on. Now we got the Variac all the way down. And that looks about right for very low voltage. Let's 50 volts. 50. Okay. 100. Okay, so she's working very well. We shut this off and we bleed it off with the bleeder resistor that's built in there. So it apparently is working quite good. Now I had to relocate this resistor as I showed you. 5U4 is eliminated because we're using 1N5408s, I believe, and we're using two of them in series so that we have 2000 volt peak inverse current breakdown versus 1000, which is what each diode is rated for. All right, I think we have got it. So we're almost ready to put this back in the case. I think we're good enough. We seem to be getting the current out of it. I haven't really ran a current check with the new diodes. Like I say, I'm going to leave the neutral fused because it's neat wiring, and if I try to change it, it's going to be sloppy wiring. Either way, the fuse will blow anyways if there's a problem, so it's not what I want to do, but that's the way the manufacturer did it, so, you know. I think we're going to end this video now. I think we're pretty much done. If there's any updates, I'll show you, but there isn't going to be much to show here. And all the wiring is clear underneath the Variac. So we're good. The only thing I got to do is to secure this and maybe shorten it up a little bit. I'll do that off camera. So that's it for this video. We'll turn this completely off. The Variac is all the way down. We shut that off. We shut it all down. We're going to put this video together, and I'm going to probably do an awful lot of editing on this to keep this short. Thanks for watching. That concludes this video.